So for the first problem, air quantity index, it just says that you will be given an integer x, you will be given an integer x, and you have to tell whether it is strictly less than 100 or not. So if it is strictly less than 100, then you have to print yes, and that's what we are doing here. And in case if it is greater than 100, then we have to say no. I just quickly covered it up because all of you have already solved this many problems. For the first three problems, I see that everyone has solved. So shall we move on to the next problem, or is there anybody having any problem here? Like it was very straightforward. Okay. So for the second problem, trade surpass. It says that Chefland consists of three countries, A, B, and C. And for the country A, it exports goods worth A1 and import goods worth A2 units. And for the country B, this is just B1 and B2. And we have been told that we call a trade surplus in case if a country exports strictly more than what it imports. And we have to find whether the country C is in surplus or not. And then we have been told that for the company A, B, and C, they trade with each other only. So it's like this. There are three countries A, B, and C. For the country A, the input is A2 and the output is A1. For the country B, the output is B1 and input is B2. For the country C, we don't know about the input and output, but we don't even want to know about it. We just want to know like the C1 and C2, if we say, we don't know about their value, but we just want to know if C1 is greater than C2 or not. If C1 is greater than C2, then this is yes, otherwise no. So I hope that this much is very intuitive. And now talking about how will you find this relation? You know that this A1 plus A2, A1 plus B1 plus C1 is equal to the total export of all the three countries. So A1 plus B1 plus C1 is total export. And since these are just trading among themselves only, so the export must be equal to the import also. You already know about A1 B1 A2 B2. So using that, you can just try to find something like C1 minus C2 is equal to A1 plus A2, A2 plus B2 minus A1 plus B1, right? From this relation, I can just have C2 on the LHS and A1 plus B1 on the RHS. So I will get to this relation. And now I can just check if A2 plus B2 minus A1 plus B1.
Like C1
If it is,
minus C1 minus C2 and if greater than 0, which means that it is exporting more.
yeah, I'm actually covering that part. That when I find this thing, I will just check whether it is positive or negative. In case if it is positive, it means that C1 minus C2, since it is positive, it means C1 is equal to C2 plus something positive, which means that C1 must be larger and C1 plus C2, that's what I want. So I can say that if the total import, this is the import of country A and B, import of country A and B is greater than the export of country A and B, then in that case I have to print yes, else no. And again for this problem, I see that most of you have already solved it. So shall we move on to the next problem? Like just after looking at the code. So in the code, since there had been multiple test cases, what I did was to just create a function which I will call that many times, as many times I have test cases. And then in every test case, I will be just taking out these inputs A1, B, A1, A2, B1, B2. And then I said that total export, this total export is actually telling about the export of country A and B. It is going to be equal to A1 plus B1 and the import is going to be equal to A2 plus B2. Then I will say that if the import is greater than export, as we discussed just now, in that case, I have to print yes, otherwise no. Just please confirm. Shall we move on to the next problem? Please write yes or no. Okay, so let's move on to the next problem. Yeah, for the third problem, it says that just one thing. Is my voice like good enough, or does it sounds awkward? Okay, clear. That's good. So here it says that chef has a total of n chocolates, and the value will always be greater than 4. The point behind telling this is just to make the problem simple. That like they are just making the problem simple. Otherwise, we would have to make some edge cases also. He decided to distribute them into 3 jars, and there are 3 conditions that every jar, like there should be at least one jar having one number of chocolate, and exactly 2 jars will like should be having the same number of chocolates, and like every jar must have at least one chocolate. So you cannot have a case where a jar is empty. And we have to tell a valid distribution of the above, like a valid distribution which has all the conditions true. So let's come up to the example test case. Let's say we have n is equal to 4. First of all, is the problem clear? Like we have been given some chocolates and we have 3 conditions that every jar must have at least one chocolate, at least one jar must have odd number of chocolates, and there should be exactly 2 jars with equal number of chocolates. So here you had to make up an observation. First of all, let's see. For n equal to 4, we can say that we will have a jar with one chocolate, another jar with one chocolate, and another jar with 2 chocolates. So every jar is having at least one chocolate. There is at least one. Actually, there are 2 jars with odd number of chocolates, and there are exactly 2 jars with equal number of chocolates. Right. Now the observation you had to make was that what if you choose 2 jars with one chocolate? This condition will be hold for these 2 jars. The second condition of having at least one chocolate, like at least one chocolate in every jar, sorry, at least one jar with odd number of chocolates will also be true there, because they are just picking up 2 jars with one chocolate. So one chocolate which is odd. And then the next condition of having 2 jars with equal number of chocolates is also hold here, but we have one thing that exactly 2 jars. It should be exactly 2. So in case if n could have been 3, then you could not have one chocolate in the next jar. But it has already been mentioned that n will always be greater than or equal to 4. So like you can have n minus 2 number of chocolates here in the third jar. This will at least be 2. So it will never be affecting this condition. It will always be at least 2. So it is also satisfying this condition. And for this condition, you don't need this jar, like these two are already satisfying it. So does it seem intuitive? And is it clear, like the problem and solution? Okay, that's good. Yeah, this one was also pretty simple. And the other thing that if n was not equal greater than equal to 4, like if n would have been greater than equal to 3, if it was mentioned something like this, then you would have to make up an edge case that if n equal to 3, then in that case do that, or but whatever. Actually, there would be no solution as well for that case. Yeah, they just made the problem simple for us. So the solution is very easy. Since we have multiple test cases, we are taking in the number of test cases as input and running up a for loop in which we have been calling this solve function. Inside the solve function, we have been taking up an input variable like an integer as input. And then we have been saying key just put up one chocolate in first jar, one chocolate in second jar, and all the remaining chocolates in the third jar. You will always have the 3 conditions satisfied. And thus we have got an answer. So is it clear? And shall we move on to the next problem? Okay, that's great. Let's see the next problem. The next problem is stamps 100, like 100, stamps 100. So what the problem says, like let me just discuss this on Notepad directly, OneNote directly. So the problem says that you will be given a binary string. Every element will be either a 0 or a 1. In case whenever you find a 1 here at any place except the last two elements, like anywhere except the last two elements, then you can replace the next two elements, whatever let them be, by 100. So this is what the problem says. And you can apply this operation any number of times. There is no foundation on how many number of times you can apply. So any number of times. Our goal is to find a lexicographically minimum string. Lexicographically minimum string. So what is a lexicographically minimum string? It is nothing but just in the same way as you see in a dictionary, that if there is something like ABB and ABC, so the first character which differs from each other, the one having a smaller character, like with the smaller ASCII value, will be considered smaller than the next one. And like it's very obvious till here. Now, talking about what we can do. So one thing which will come to your mind, which should come to your mind, is that whenever you apply the operation on any place to convert the three elements to 100, if there is a 0 and you apply an operation at this point, then this is just making your answer worse, because you are getting a 100 here, which is definitely larger than what it initially was. So there is no point of applying an operation on a 0. Does it make sense? Does it make sense that if we have a 0, there is no point of applying the operation at that point? What if there is a 1? Should I apply the operation here? So one thing you can see is that it will just convert it to 100. Uh, Maybe you have some advantage, maybe you don't have it. But like, oh yeah, by the way, this case is not generic. Like we will see that this is contradicting. I'm just telling about the intuition, that the way I approach the problem, and I think that you should also approach in the same way, maybe, or you can have different approaches also. So here, if I have a 1, maybe I can have a 0, 0, 0, 1, 1, 0, 1, 1. In all of these cases, applying the operation is making my string smaller. So whenever you see a 1, just apply the operation. Now, one thing you could observe was something like this. What if the string is 1, 0, 0, 0, 1, 0, 1? Or maybe let's just take up 1, 0, 0, 1. According to our logic, it will just remain to be 1, 0, 0, 1. But that's not correct. The thing which you could have done was something like apply an operation at this point to create it to 100, which will make the string to be 10. Like applying an operation at this point will make the string to look like this. Then you can apply the operation at this point, so it will become 1000 if you apply the operation at this point. So the minimum answer for the string 1001 will be 1000. From this example, like obviously in competitive programming, as I told about the intuition earlier, the intuitions can be wrong. So it certainly did make give you a good way that yeah, this is better. You have been just going on the good side, but it might not be optimal. So you have to make up some test cases. And from like if you make up a test case like this one, and then you can see that whenever I find a 1, like at any point after some zeros, whenever I find the first one, I can just apply the operation everywhere to make up all the elements as zeros. Like except the last two elements, I can make up all the elements as ones first. Then like I can just start applying the operations in this way. Or maybe I could have directly started from the right side. So basically the point is that whenever I find a 1, after this I can make up all elements as zeros. and initially all the elements on the left side were also zeros. So this is something I can always do. Does it make sense? Or should I explain a little more for this thing? Let me just make it anyways. So the thing is, whatever string you have, let's say I have something like this. You can remove this one. How can you remove this one? Like for this one, this one, this one, this one, this one, you can just remove all these ones. Because if you apply an operation at this point, it will remove these two. Apply operation at this point, it will remove these two, and similarly, like you can just start applying operations from right side one by one to remove all the ones to zeros and make up something like this. Then apply the operation at this point to make up something like this. So the point is that all the ones after the first one which has been coming, after this, all the ones you have can be uh, like converted into zero, can be converted into zero without actually making any like making the number smaller, larger. So this is always gonna be possible. You can have anything, then a one, then anything. You will just convert the string like some zeros, then a one, then anything. You don't really care about it. You will just convert it to one, 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 like 0001, and all the numbers to be zero now, whatever it was earlier. So does it make sense now? Just write yes or no inside the chat that does it make sense? And shall we move on to the code, or anybody having any query regarding the logic or even about the intuition that how you could think about it? Okay, so if it's clear, let's move on to the code. For the code, what I've done, like again, multiple test cases. So just taking up the number of test cases as input and running up a for loop, and we're just calling the solve function again and again. And here I'm seeing that um, just taking up the number of like the size of the string as input, then the whole string. And then I initialized a variable with name first as n, like you can do in any way. This is the one way I did implement, like for keeping it very beginner friendly also. And then I just ran a for loop to find the first occurrence of this one. Like just find the first occurrence of the one. But here notice that I'm not considering the last two elements because I can never apply the operation on the last two elements. It has already been mentioned. So I'm skipping the last two elements and just finding out the like first occurrence of one. And as soon as I find it, I will just break the loop, and then like first occurrence onwards, I will convert all the elements to zero because this is always possible for me. And then I will just output the string, and it did pass. So is it clear or any doubts? Okay, that's great. Yeah, so let's move on to the next problem. The next problem is concussive sequence. The problem says that for a sequence x of length L, having length at least 3, we call we call x to be a concussive sequence if and only if there is a condition. We will discuss this. And we have been given a sequence A of length n. We have to rearrange it in such a way that it becomes concussive sequence. And in case if it is not possible, then return -1. If it is possible, then print any arrangement. So what is a concussive sequence? Like not just this problem, but you will be seeing this kind of pattern a lot of times. A concussive sequence is something like this. The first number, or not like this, let's keep it simple. Any number I is gonna be either like this, larger than, like smaller than both its neighbors, or greater than of its neighbors. Okay. So one thing which you could notice was that since AI will be larger than this or maybe smaller, in both of the cases, the other one can not be of the same type. So if AI is larger, like smaller than both of its neighbors, then for A of I plus 1 and A of I minus 1, they must be larger than both of their neighbors. And in this case, where AI is larger than both of its neighbors, then the neighbors must be smaller than both of their neighbors, unless they are the last element. And for the corner elements like A0 and A of n minus 1, there is no such condition for them. So now we have to build up something like this, where A0 is less than A1, greater than A2, less than A3, greater than A4, and so on. Yeah, either the sequence would be looking like this, where every element, like the condition, the inequality is changing, or it would look like this, where A0 is initially larger, and then A1 is smaller, then like larger, then smaller, and so on. Why are there only two sequences? Because we had choice only for the first element. After the first element itself, there are no choices. It's fixed that if this sign is like this, then the other sign would be like this only. So do you understand that why we have only two choices? You can just write, like if anybody has any query regarding this, then you can just ask it. I think that this is very obvious, so I'm not really spending much of the time at this. Now the thing is, how will you rearrange the elements? Let me take up an example. Let's take this example. 1, 1. So we have like 1, 1, 1, 2, 2. Oh yeah, first thing 1, 1, 2, 2, 1, 1. So the input is something like this. But even if the input was something like this, what will the answer change? Will the answer be different or the same? Obviously, it will be the same because the order in which the numbers have been given doesn't matter since I have to just rearrange them now. It doesn't really matter which elements were present where. Only the what matters is that which elements were there. So it's definitely better to just sort them. Now, what I said was that, hey, I will be having it something like this. So either I will fill the smaller numbers, like I will be filling them in this way. That maybe let's keep it simple. That if array B is having all the same elements of the array A but in sorted order, then I will say my answer to be something like B0, B1, B2, B3, and B4 in this way, where I know that this element would definitely be smaller than B3 unless like it would either be smaller or equal. We will see that what can happen. It would either be smaller or equal. B3 would either be greater or equal. B4 will either be larger than B1 or equal. And then B2 will either be smaller than B4 or equal. So the inequality, like this relation will hold. I think it is also known as Wiggle sort or something like this. Wiggle sort, I guess. Yeah. So the main thing is, if you rearrange the elements in this way, you are guaranteed for this relation. But here we don't want this in like we want it to be either this or this, not like this. They should not be equal.
Will the
So
sequence always contain the odd number of elements?
no, it can contain even number of elements also.
Like, can you explain?
Like
What?
let's say if there were four elements, you will place B0, B1, then B2, B3.
Oh yes,
Yeah, like no problem in that. So like this is something that you can even remember, or you don't remember this, but as you keep solving problems, you will see that this is something you can like, will be very intuitive for you. That either you start placing the smaller element from this point, at these places, like for even number, it doesn't matter whether you place them at these places or the other one. But for odd, there are like two ways. Okay. So let me use two colors. So it is something like this for odd number. For even, it doesn't matter from where you start placing. है ना? We are gonna be placing at alternative places. So if we place an B0 here, B1 will be here, B2 will be here, and then we will start placing B3, B3 and B4. Or the other thing can be, I start placing B0, B1, B2, B3, B4. Right? These are
I
the two
forgot.
ways.
I forgot what B consists of. It consists of all the.
B
What is
consists
B
of
here?
all the elements which were present in A, but B has been sorted. Or you can
Okay.
just assume that I have sorted the array A and I'm just naming it as B now.
Okay.
Yeah, basically instead of sorting the given array, uh, though you can sort the given array, and like in my code, I also sorted the given array, but you can do something like creating a new array and sorting it so that you don't lose the given inputs in the exact same way. Though it doesn't matter. For if anybody has any confusion, you can just say that B is nothing but sorted array A in sorted way. So as we discussed that we can have two things. Either we can have like this, or we can have like this. So in the above way, like in this way, I will have my larger elements at the corner and like alternate places like this. And in the other way, I will have them at this places. And the smaller elements at yellow places. So you just try out both of the ways. You just try to place elements in both of the ways. In one of the way, you just say that, hey, I will place it in this way, A0, A1, okay, B. I was using the word B. B0, B1, B2, B3, B4. You see that the equality can hold. Like either they can be equal or not. So I will just place it in this way and then check if any elements are equal. If there are any elements equal, then that's not a good thing. And otherwise, it's already good enough. And in the other way, I can place them either B0, B1, B2, B3, and B4. Oh, sorry, I think I wrote it in activity. It should be like this. Yeah, so it should be like this. I wrote it again wrong. It will be like this. Yeah. So here the condition is being held. The element B0 is smaller than both of the neighbors. This element is smaller than both of its neighbors. This is greater than both of its neighbors and greater than. Like you can just verify that this is actually going to hold unless two elements are equal. Now, when I've constructed these two arrays, for both of the arrays, I can just check it one by one. If any two elements are equal, I will just say that, hey, I didn't find my answer. So I will just say that not correct. Does it make sense? What do you think? Like, does it make sense? Please tell yes or no inside the chat. This is something quite standard, so that's why I'm not really willing to discuss it completely. The solution is the models of the array template into elements and Share will see your message after the session. It's quite long.
Okay, sir.
And like anybody having any queries, then please just ask it. Otherwise, we can go ahead.
Sir, basically, so my doubt in this question was, like we can, so we can think of it in a way like, we sort the given input array,
Yeah.
and first we push the first element, then we push the last one, then we push the second
Yeah.
element, then second last, like that.
Not exactly correct. It, I think it's not correct. No, wait, let me see once. Yeah, it's not correct. So
Oh,
if there is something like one, two, or maybe let's say one, one, two, and three, two. Like if you push the first element, then the last element first, last, and then the first. In this way, you can have a collision like this. But if you had been placing one, 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 then two, sorry, one, one, two, then two, and then three, in this way, then this element and this element will be far away.
so like the array will have to be sorted first, and then
Yeah.
we
So like
can
you
try this.
sorted the array to be this, then you place the first element here, last element here, first element, last element, and then last first element. So you got the collision now.
Okay,
But
okay.
if you had
Yes.
been placing like this, it won't have any problem.
Yes, sir. Yes, sir.
Like this is something standard, so you can even try to remember this for the future. Or otherwise, you will just get it into your memory directly by solving some more problems. Now coming up to the part when we have created it, like this is the wiggle sort. The problem was nothing but indirectly asking for this. Now you can just check whether it is valid or not. If it is valid, then just print it. Otherwise, check for the next one. If it is valid, then just print it. Otherwise, just print minus one. So that's what I did in the code. Here there are multiple test cases, so I just took them and input. By the way, you can ignore this line. Like these are nothing but just lines for connecting the input-output files in my IDE. And this is also something related to my IDE. You can ignore them. Here I said that just taking out NS input, like the size of the array, then taking the array as input, then sorting it. Yeah, as I said that you can directly sort this array also, but generally it's a good habit to create a new array and sort that so that you don't lose the current inputs. But here we didn't care about it, so that's why I just made the sorting directly. Then I created two new arrays, B and C. One of them I just placed in this way that starting from index 0, I will place an element. I will just place the current element. Then I will increment index by 2. And as soon as my index goes like out of the array, so I am just saying that I will place my first element here, then increment the index by 2. So place next element here, then next element here. After this, when I increment it by 2, it would be pointing somewhere outside the boundation of array. So in that case, when and will be greater than equal to n, I will just set it to and equal to 1. So it will start from here again, and at the end it will just like cover the whole array. So that's how we do write it. Again, something quite standard. And then for the array C, I just like initialized and by 1 once again, and iterated over the array again. Here, notice that I set and equal to 0 because in the array C, I have been covering these two, and then I want to cover these. So that's why I'm starting with and equal to 0 now. After that, I just created a function. This is a lambda function. Like if you have not seen inline functions till now, then don't worry about it. This is nothing but just a function, like taking a vector as input and checking if it is valid or not. So I just iterated over the array, and just to be on the safer side, I applied the same conditions as being mentioned in the problem. That if it is greater than both of its neighbors, then it's okay. If it is smaller than both of its neighbors, again it is okay. Otherwise, just return false. And if it doesn't get to false at any time, then just return true. Then I declared the answer to be -1 initially. Like I will be just printing out every element of the answer. So this is nothing but just lazy way of writing the code. The lambda function, like you can study about it at GFG. For now, in the PCD session, I can't discuss much about it. Or you can just create a normal function, like normally. You can create it normally also. This is nothing but just doing this work. whatever you write.
What did you store in the B vector and in the C vector?
This B and C vector are na, these two vectors, like whatever values I stored it. In the problem, I'm not creating a V vector for this part. I'm just sorting the array A itself. And these arrays, like this sequence, I'm calling it as B. And this sequence, I'm calling it as C, or you can give C and B like reversibly.
Okay.
Yeah, and then I'm checking. Just I created a verify function in which because I had to like do the same thing again and again, so that's why I just created this function once to apply on B. If it will just verify if B is correct. If it is correct, then answer equal to B, and then it will be just printing it. Otherwise, we will check for C. If it is there, then say answer equal to C and then print it. Otherwise, answer won't change and it was initially -1, so -1 will be printed. Obviously, you can have different ways of implementing the same thing. Since the code are not like two-liners now, there can be different ways, different opinions.
After sorting the array, I didn't quite get what logic did you apply. After sorting, can you explain by like the
This part,
example of
this
after
part.
sorting the array in the code? I did not understand.
Okay, okay. So after sorting, this is nothing but I'm saying that I will go for all elements. If you see, here I had been going for B0, B1, B2, B3, B4, B0, B1, B2, B3, B4. I had been placing in this way, right? And I had to place it somewhere. So at what index I will place it, I'm storing it inside the variable ind, integer ind. And here I've been just saying that uh, b of ind equal to a of I. In case if ind is outside the range of the array, then it will say ind. In case if that happens, then ind equal to 1. So just coming back, and you don't need to push yourself to understand my code in case you feel uncomfortable. You can just write up your own code. This is something quite basic.
So the sorted array you are placing it alternatively, and when you are reach the last part, you are going back to the first part.
Yeah, you if you want, you can run up two for loops. It doesn't really matter much, or you can have two variables for this. Just try it yourself, and then you will understand that why I did this. What was the point?
Okay.
So let's move on to the next problem. Just write yes or no inside the chat, whether you understood or not. In case if anybody has any query, then please tell me. Okay, that's great. So now last problem which we will discuss now, prime permutation. So the problem says that we have to find a permutation of first n natural numbers, permutation of first n natural numbers, which is 1 to n, which is nothing but 1 to n. And there should be a condition, like we have a condition that let's say p is my permutation. I hope you understand. I hope you understand about this. That p is an array which contains every element from 1 to n exactly once in any order. So that's what I've been calling as a permutation. In that case, I want to have p of I minus I for all the elements, like the absolute difference between p and I for all I in the range from 1 to n as a prime number. Here, this array and I are one based in like one based index is given the name. So please tell me whether the problem is clear or not. Though the problem was quite straightforward here also. Just please tell me in case if anybody has any query regarding the problem statement. And if it's clear, then I can come up to a solution or some approach. Okay, I think it's good enough. So for the problem, uh, I will be just given the integer n. I will be just given integer n, and I have to create this permutation such that this condition holds. Now, one thing which I could notice was something like this problem is constructive and you need to observe some parts. You might feel that how would you observe it? So like you would have to put up some more efforts. I will be just telling you about the way like I got the approach. So I noticed in the problem that when I have four, like since I want the absolute difference of pi and I to be a prime number, so I thought that what if I take two? What if I create a permutation like 3, 4, 1, 2, where every element, like from the index are 1, 2, 3, 4. So every element is having a difference 2, and it really sounds good. It really does sound good. But the problem was, what if n is equal to 5? You can't really do this. You can try to do this. Since I have to keep the session short, so I can't really tell about all the places where I tried to think and got it wrong. I'm just telling about the main parts. So for n equal to 5, you can't really do this. And I think that it was already mentioned in problem. Yeah, it was already mentioned in the cases also that there is a way 4, 5, 1, 2, 3. The indices are 1, 2, 3, 4. So the absolute difference here is 3. It is 3, 2, 2, 2. I got one thing in my mind. I got one thing in my mind. What if n equal to 6? I can do something like 4, 5, 6, 1, 2, 3. The differences in the indices will be like 3, 3, 3, 3, 3, and 3. Everyone will be 3. But if n is equal to 7, I got up with the permutation that I can have something like 6, 7, 1, 2, 3, 4, 5. Again, like 1, 2, 3, 4, 5, 6, 7. So the differences are 5, 5, and 2, 2, 2, 2, 2, which are all primes. So after coming till n equal to 7, when I tried to think about n equal to 8, I just saw that, hey, I can place the first four numbers. I know how to place the first four numbers. I know how to place the another four numbers. Like here, I had to just place 1, 2, 3, 4. For the indices 1, 2, 3, 4. Then I have to place 5, 6, 7, 8. For the indices 5, 6, 7, 8. So if I just do the same thing, like for placing these numbers, if I have a permutation like 7, 8, 5, 6, it will be valid, right? It will be valid here. So the thing is, if I have uh, like this thing made one thing clear. If I have something like n equal to 1e4, I don't really care about this one. I just care about uh, what if I do n mod 4? Like just try to find the remainder. In this case, it will be 0, but yeah. So it can be 0, 1, 2, or 3. If it is 0, then I can just keep repeating this thing. Like place elements in this way, every four elements in this way. Like 3, 4, 1, 2. The next four elements as 7, 8, 5, 6. Then the next elements 9, 10, 11, 12 would have been like 11, 12, 9, 8. And in case if you can't understand that how is this valid, then it means that you have to spend some more time on your own before going further in the editorial. Like this is something you have to do yourself. Nobody else can explain, like can make you better by explaining this. So if you are good to go till here, like just please confirm it once. How many people are like with me right now? How many people have understood the things which I discussed now? That for finding for 4, then for 5. Yeah, what are you saying? N mod, sorry, please repeat. Yeah, I will be coming to this again. Okay, so let me do this. What I said was that if I have n equal to 4, I can just say 1, 2, like for placing the numbers 1, 2, 3, 4, I can have something like 3, 4, 1, 2. If I had something like n equal to 8, in that case, I could have said something like here I have 5, 6, 7, 8, which I have to find a permutation. Do I really care about the values? Like the indices will be 5, 6, 7, 8 also, and the values are also this. So what if I find the permutation like 7, 8, 5, 6? I know. If I give you some idea about the way I got the intuition, like the way I confirmed this, it was that I have to do something with the difference of the element and the index. Since the elements range is 5 to 8 and the index range is also 5 to 8, the difference is like it doesn't really matter whether I have to do for 1 to 4 or for 5 to 4, 5 to 8. The same method will work. So from there, I just got one thing confirmed that even if I have to build for 99, I don't have to build up the test case for this. I can say that, hey, I know for 92 till 92, I can just have something like 3, 4, 1, 2. Then keep doing this, keep doing in the same way till 92. After that, I will have just 7 elements left. And how to place those 7 elements? Hey, I have done this already. I have got this. So I just saw that. Hey, I just need to find out for n equal to 4, 5, 6, 7. And after that, the same thing will work. The same, exact same thing will work. Okay, so does this make sense now? I think that uh, for this problem, I have explained it more than I should have, just for somebody who is not very comfortable with it. And at this point, I would say that in case if you're not able to understand it properly right now, it means that you need to spend more time on your own. Otherwise, you won't have much benefit. Makes sense, but how do we get the intuition for the mod 4? Yeah, for the intuition of mod 4, I just told you in the same way that as soon as I reached for 8, I saw that for the first four elements, I know how to make. For the next four elements, it is just same thing. So I didn't have to build up anything new. Now let's say if I had to find for n equal to 5, sorry, n equal to 9, I could have split it up into 4 plus 5, n equal to 11. Yeah. So if I have something like n equal to 11, I can say that this is nothing but for the first four elements and for the several elements, just find up their permutation. Or and obviously it's not necessary for you to have it 4 only. You can split it into 5 plus 6 also. It's up to you. You can split it into 7 plus 4 also. Like the main idea was that if you have four elements, four consecutive elements in the same range, and the indices at which you are willing to place them are also the same, then it doesn't matter which elements they are. This was the main intuition. This was the main observation. So for any number, let's say I had 99, I could have set it to be 5, like uh, 19 times. I will just have a permutation of 5 and then the last permutation of 4 in any way. I chose the permutation of 4 because I felt it to be like very simple for me. Does anybody want me to dry run for a case? Okay, so let's take the case for n equal to 11 itself. Let me do a dry run also. And I highly recommend it if you didn't understand the above part and you have been watching on YouTube, then just please stop it right now and spend time on your own first and then come back. For the live audience, you can just be there. So it's something like I will place For 11, I will say it to be equal to, like, let's say 5 plus 6 only, or keep it in the way I want it. Just say it to be raised keys. Yeah. I will call it to be 7 plus 4. So first of all, I will have a permutation of 7. I can have it in like 5, sorry, 6, 7, 1, 2, 3, 4, 5. I have already calculated how to permute 7 elements. And then for permuting 4 elements, where the range is from 8 to 11, I will say that, hey, place 10 and 11, and then 8 and 9. So the indices are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The differences are 5, 5, and then 2, 2, 2, 2, 2, 2, 2, 2, 2, and all of them are prime. So you got it correct. Just confirm it in yes or no whether it is clear or not now. Yeah, you could have done it to be 4 plus 7 also. Like, it is very flexible. The main idea was that if you have 7 elements, where like in any range, like from low to high, like any number of elements, low to high, and the indices are also in the same range. So it doesn't matter whether it is from 1 to n or from 7 to n plus 7 or something plus 6. It doesn't matter. So shall we move on to the next problem? Sorry, there is no next problem. Shall we move on to the code? Okay, so let's move on to the code then. So for the code, again the same thing, multiple test cases. You can ignore these lines and you can ignore these lines. So they can, yeah, there can be multiple ways of implementing it. I just went up with a very simple one, that the n can be like 2 or 3 also. For 2 or 3, I just manually tried to do it, just some different permutations, and it was not possible. So since I had just tried it and I know that it is not possible to permute 2 or 3 elements in the given way, I just return -1 for them. And for all the other elements, I realized that yes, it is always possible. I declared a variable with name start and remainder. Like, this RAM is actually telling me about the category. I decided that for any number n, let's say it is something like 99, I will just mod it with 4 to get something like either a 0, 1, 2, or 3. And on that basis, I will decide ki, apart from all the fours which I pick, whether I have to pick a 5 or a 6 or a 7, or this means that I don't pick anything, like fours are enough. And again, something uh, quite easy to do, but if you are not like comfortable with the things which we have discussed earlier, then you might get a little confused, and for that you have to spend time on your own. Like, watching the video won't make you better at that point. So here, if RAM equal to 1, it means that this is something like a category 5 for like uh, category 1, where we have to permute 5 elements first. I'm just permuting them, just hard coded the permutation, and said that now I have to start the permutation from 6. Now I know that for all the remaining elements, I can just group like have 4 pairs of 4 elements, and it would cover all the n elements. Then similarly for m equal to 2, and similarly for m equal to 3. And after that, I just did enough like while loop, that while start is equal to or less than or equal to n, just print up 4 elements and increment start by 4. So at the end, you will have all the elements being printed and just leaving a line at the end. So is it clear? Like, I'm not expecting you to just uh, mug up the code. Okay, that's good. So for the people who have been watching this video on YouTube, if you like the session, then you can please like the video and subscribe to the channel if you want. And please make sure to go to the comment section and give your valuable feedback. In case even if it is bad, just please give it. If you give suggestions, then we can improve and give us like feedback, like honest feedback. So thank you for watching the video, and bye.